Welcome to EDU World Space.
A beaker of water rests on an electronic balance that reads 998 grams. Just 998 grams. We have a 2.6 centimeter diameter copper ball is attached to a string, like so, and is suspended in the water, but does not touch the bottom. What are the tensions? What is the tension in the string and the new balance reading? And this is 2.6 centimeters. So we have the diameter of the ball is 2.6 centimeters. Radius will be equal to 1.3 centimeters, which is 1.3 times 10 to the power of minus 2 meters by divided by 100 to get the meters. So we need the density of copper. Before we go and get that, let's decipher all that is happening here. So the things that are contributing to the tension in the string and to the total mass of the system is the tension, rather the mass of the copper ball. We also have the upthrust or the buoyant force produced by the water here. So these two things are going to be affecting the reading, rather the reading of the tension and the strength. So the buoyant force is equal to the weight of water displaced in the beaker. And that's equal to the mass of water displaced, which is the same, mass of water displaced multiplied by the exertion due to gravity. And the mass, from the density formula, density is equal to mass of volume. Mass will be equal to density times volume. So this will be equal to the density of water times the volume of water displaced times the exertion due to gravity. And the volume of water displaced will be equal to the volume of the object in here. So we need the volume of this, and that's for the buoyant force. Now, as for the mass of the copper ball, which you want to get the weight of the copper ball, that'll be equal to density times volume of the copper times the exertion due to gravity. So let's find the volume of the copper ball. V, this is a sphere. This will be 4/3 pi r cubed, which is 4/3 times pi times the radius, which is 1.3 times 10 to the power of minus 2 all to the power of 3. So solving this should be equal to, which is 9.203 times 10 to the power of minus 6 meter cubed. So the weight of copper, we still haven't found the density of copper. From Google search, we can find that it is 8.96 grams per centimeter cubed. So it's 8.9 in kilograms per meter cubed. That would be 8,900 or 8.9 times 10 to the power of 3 kilograms per meter cubed. So the weight of copper will be equal to the density of copper 8.9 times 10 to the power of 3 times the volume, which is 9.203 times 10 to the power of minus 6 times g, 9.8 meters per second squared. This will be equal to 0. 0.803 newtons. Now, as for the buoyant force, this would be equal to the density of water, which is approximately 1000 kilograms per meter cubed, times the volume of water displaced. That's the same as the volume of the copper ball. 9.203 times 10 to the power of -6 times G 9.8 meters per second squared. This will be equal to 0.0902 newtons. That's the buoyant force. So the first part of the question asks us to find the, so the tension in the string will be equal to, let's go back to the diagram. Like we said, the tension in the string is here. We have the buoyant force pulling upwards and this pulling downwards. So we need to subtract. So the buoyant force minus the weight of the copper. So taking the force balance, we can add up all our upward forces and equate it to the sum of our downward forces. So T plus FB will be equal to the weight of the copper. That would mean T will be equal to the weight of the copper minus FB, which is equal to 0.803 minus 0.0902. This will be equal to approximately 0.713 newtons. The second part of the question asks us to find a new balance reading. Now, the new balance reading, we have the balance on the bottom. We have the weight of the water, of the beaker, and the water in it. So, from the buoyant force, we know that due to Newton's third law of motion, being that action and reaction are equal and opposite, there's going to be a reaction force from the buoyant force acting on the ball. It will create an equal and opposite force from the ball acting on the water. So we're also going to have the same magnitude as the buoyant force pushing down on the water as the water is pushing down on the ball. So that's going to be in the system of the water on the mass balance. It's going to affect the weight of the water, the weight of the beaker. So this was for A. Now for B, we're going to have the original mass, which was 998 grams, plus, back to this, need the buoyant force. And this is just going to be a weight. So let's find the weight of the copper in the water. That will be the buoyant force divided by the exertion due to gravity, which is equal to 0.0902 divided by 9.8. That's equal to, sorry, this should be mass, not weight. So this is M, mass of the copper and water, is equal to this divided by this, which is 0.0092 kilograms. Because we're dividing newtons by the acceleration due to gravity meters per second squared, all in SI units. So let me convert this to grams. This would be 0.0092 multiplied by 1000, and that's our grams, which is equal to 1239.2 grams. So we have 998 grams plus 9.2 grams, which is equal to 1007.2 grams. And that's our second answer to this question.